Hi, Tony back with you today, the electrician. I'm going to show you a video today about solar and DC isolation. This is inspired by Mark the Spark Allison, who just did an excellent video on MC4 connectors, these connectors here. And you should just go and look him up, Mark Allison, electrician. So today we're going to just quickly run through this 50% done complete install of a solar array system. Starting over here, we have batteries at the bottom. They always go the lowest because they're heaviest. There's going to be another battery above there. And we come up now to our isolation. This is our DC battery isolator. There's a big chunky 100 amp type isolator. It's not wired yet, as you can see. It's all in progress. We come up here now to our AC isolator, which is the kind of standard electrician's isolator you'd see for EV chargers and that type of thing there. What we're going to do is we're going to be coming from the fuse board, from our inverter here, into the AC isolator and up to the fuse board, which is up here. Ignore this, it's just an alarm panel. So the AC isolators are very simple. We always know them. If you got your top left there, basically when you switch your isolator off, it breaks to the top, and when you switch it on, it connects from the top left to the bottom left. And then all of the others are the same. They're basically just a parallel vertical connection. However, our DC isolators, which we're going to talk about today, are completely different. These are a rotary type of isolator, as you can see here. I'll switch this one on here, and I'll switch it off here. What it's actually doing is turning a disc inside. A tumbler is turning inside, and it's turning a disc inside, which is what you might call rotary isolator. You might call it a crossover switch. Some people like to call it a crossover switch. So instead of going from the top left to the bottom left like we are in our AC isolator below, these are wired absolutely differently. They're a crossover. So your top left here actually connects to your bottom right over here. And you can see the terminals say number 1 on the top left, and it actually says number 2 on the bottom right. There is a drawing. All of these isolators come with a very kind of complicated engineer's drawing of how they work, and you can follow the terminals 1 to 2 as it's drawn vertically here. It's not vertically, it's actually a crossover, like I said. So the first termination here, number 1 top left, connects through to bottom right in a kind of cross pattern there. Over on the top right, that will connect through to your bottom left. So what you have in effect for your two different poles, your positive and your negative in this case, is a large cross happening here as far as termination is concerned. And then on the inside, we have a smaller cross inside the large cross. So this one here, this termination here, will connect actually through to the opposite side on the and the smaller internal cross. And this one here, marked number 5, will go across to number 9 here. So you can follow the drawings, but the drawings can be a bit misleading. A lot of sparks probably get confused and end up belling it out to try to work out how these things work. There is other clues, however. This rotary disc is on different levels of steps, as you can see here. This step is right at the very lowest, and this is the very top. So if I follow this very top tool step, it actually corresponds to that very top tool step there. And if I come inside now, number 5 here will correspond to the one that's at the same level, just below here, like I said, number 9. So here we've got a classic example of how these switch. 2 crosses are the easiest way to remember this. So for practical purposes, we have an installation here with an east-west solar array. So we have an east roof with I think 9 panels on there, and we have a west roof of 10 panels on there. This is just the east. This is the east one here. And what I have here is my reasoning for using 2 separate DC. I know that this is a 4-pole device, and we could kill both strings back into our inverter with just one device, but I like to use a separate DC isolator for each string of solar arrays up on the roofs. There's 3 reasons why I like to do this. 1, they're dirt cheap. They're like 25 euros each, not very expensive at all. Number 2 is, for instance, if I had a maintenance issue up on the east roof, I could turn just this one off and leave my west roof working. I might have pigeons underneath there. I might just not want it on for, you know, a 2-week period. I might want to clean it, anything like that. I've got the ability to isolate the 2 strings separately. Now this string, for instance, here is 10 Jinko 435 watt panels, and that they are about 12 amps each and 36 volts each. So because we wire them in series, that's 360 volts DC going through these. So that can lead to a big, mighty big arc when you disconnect. So when I turn this on here, we have no problem at all. DC is quite happy, don't mind the screw, quite happy to connect with no arc at all. But as you can see, it's a sprung load tumbler, which is designed to break it really quickly on the last moment there. And there's the screw gone onto the floor. This has the effect of snapping the terminals closed to minimize the arc across the terminations. So the reason why I use a separate one for each string. Also, the third reason is because I like to double cross my terminations. What I mean by this, I'll show you. Here is my MC4 connector for the positive on this east array, and at the top here, as you can see, the cable's going up into the attic, into the sub attic, and then through the roof up into the main attic, and eventually connecting to a shunt, a fireman switch up above, which is another isolator that's going to go here. Our terminations are coming from the roof effectively. Positive in here is this one here, termination number 1, which when I close that connection, it will go through to this terminal here, number 2, as I explained earlier. And what I've done here is I've taken a loop out of number 2 and gone up the side and brought it round into number 3 here. Now this is a bit of a cheat. So what's going to happen now is when I close it, as I just did, it's going to not only close this one, it's going to close this one as well. And as you can see, the corresponding terminal here, number 4, is the positive going out here to my MC4 into my inverter. So what I've done in effect is I have closed it in 2 positions. So this 360 volts is going to be snap closed in not 1 but 2 positions. Now what this does is it throws the arc right out, and you're not just halving the arc, it's more like a quarter. So for maintenance reasons, I always double cross my terminations, and the little drawing that I showed you earlier will show you examples of doing that as well. I do this to reduce the arc and prolong the lifespan of the device. Thank you very much for listening today. Goodbye.